the video will cover the first part of the factoring lesson, and we're going to start with a very basic concept of factoring, which is the greatest common factor. And I will refer to it as the GCF, okay? Greatest common factor. So when we look at numbers, let's say two numbers, the greatest common factor is going to be a number that could divide both numbers, but not any number, the biggest of all. So just quickly here, we have 28 and we have 40. We know both numbers are divisible by 2, right? However, that's not the greatest number that will divide them. So we'll get to that problem in a minute. So how are we going to find it? We're going to write each number as a product of prime numbers. And so before we move on from there, let's just establish quickly what are the prime numbers. So prime numbers are numbers that can only be divided by what?
1.
By 1 and what else?
Themselves.
And, okay. So which one is the first prime number?
1. No, 2.
2. 1 is the exception. So 2 is the first one, and then?
3, 5, 7, 11, 13.
So how come 6 is not a prime number?
It's divided by 3.
By 2 and 3 is even, right? So all even numbers are out of the list of prime numbers. Okay, what else?
13, 17, 19, 23, 27.
No, 27.
Oh, I mean, yeah.
29.
29. 26 is even.
31. 37.
41.
Okay, so I'm going to stop here because I could actually go on forever, right? How many prime numbers are there?
A lot.
An infinite amount.
Yes, infinitely many. So, but I don't think when we're dividing, I don't think we're going to require numbers bigger than that. So when we say list a number as a product of prime numbers, we can only use those prime numbers, okay? Identify the common prime factors. That will be step 2. So common prime factors. And step 3 will be to write the product of all common prime factors found in step 2 is the greatest common factor. So the product of all common prime factors. That will be the GCF. Greatest common factor. Now, if you find that the numbers have no prime factors in common, then the GCF becomes 1. That's cool. All right, so let's start with our two numbers from example 1, and we have number 28 and number 40. So some people like to do the prime factorization vertically, others horizontally. So I'm going to teach you, both ways. It's the same thing. So 28, remember, we can only divide by prime factors, okay? So what can we divide 28 by, Julian? 7. And if we divide 28 by 7, we get what? 4. Okay, so Design, what can we divide 4 by? 2. So 4 divided by 2 is? 2. And what can we divide 2 by? 1. Bigger than that?
2.
Another 2. And then we get 1. So the idea here is that you stop once you get that 1. Okay, now let's look at the next number, which is 40. So, Celia, what can we divide 40 by? Well, 2, yes, because it's even, right? So 40 divided by 2 is 20. And then, Leslie, Ramirez, what can we divide 20 by? 2, and we get 10. And then, Anka, what can we divide 10 by? 2, and we get 5. And then what can we divide 5 by, Mateo? 5, and then we get 1, right? So that's it. Those are the prime numbers, the prime factors of those two numbers. So now what I'm going to do is just list them. horizontally. So 28 is the product of 7 times 2 times 2 times 2. I'm sorry, only 2 2s. And 40 is the product of 2 times 2 times 2 times 5. So now let's see, what do they have in common? So they have 1 2 in common, right? And then they have a second 2 in common. What else do they have in common?
That's it.
That's it. So then what I'm going to say is that the GCF of 28 and 40 is equal to 2 times 2, or in other words, 4. Now, maybe you could tell that just by looking at the numbers. Maybe you couldn't. So sometimes you could just tell right away. Other times you have to rely on the prime factorization and then take the common prime factors. Now let's work on problem B. So for problem B, we have 55 and we have 21. So if we do the prime factorization of 55, we can divide by 5, we get 11. Now 11 is the prime number, so we can only divide by 11. So 11 divided by 11 is 1. Now let's try with number 21. So 21, we can divide by 7, we get 3. Divide by 3, we get 1. So now, as you can tell, 55 is the product of 5 times 11. 21 is the product of 7 times 3. And so, do they have any common factors?
No.
They don't, right? So if they don't have any common factors, by definition, we get that the GCF of 55 and 11 is equal to 1. All right. So now I would like for you guys to practice.
With the GCF 21.
I'm sorry?
55 and 21.
Oh, I put 11. Sorry. 21.
If you can correct it, you can understand that she meant 21.
No, that's okay. I've been making a lot of mistakes lately. I don't know why. So I want you guys to do the prime factorization of the numbers 15, 18, and 66. And then let's see if we get the same answer. Now, moving on to the third problem. So we have numbers 15, 18, and what was the other one?
66.
66. Okay. So, Gustavo, tell me, what is the prime factorization of 15?
5 times 3 times 3 times 1.
Okay, very nice. 5 times 3 times 3. No, 5 times 3. Only 5 times 3. Yes, so 5 times 3. All right, and then Christopher Luevanos, what is the prime factorization of 18?
6 times 3.
Well, and 6 could be also factor into 3 times 2, right? And then you said another 3. Okay. And then David from St. Drew. 66.
22 times 3.
Well, let's say 11.
Times 2 times 3.
Yes.
Okay.
That will be, remember, you can only use prime numbers. Now, let's see what they all have in common. And it has to be in common for all 3 numbers. So all of them have a 3. Right? Now, you can see that 18 and 66 have a 2 in common, but 15 doesn't. So should we take 2 into consideration? No. We cannot. And you could tell because 15 cannot be divided by 2. I mean, you can, but you will not get an integer. So in this case, the GCF of numbers 15, 18, and 66 will be only 3. So let's go to the next slide. Now, here we have variables. And for variables, I want you to write the following statements. So, to find the GCF of a list of variables, use the variable with the lowest exponent. So we have the GCF of the variables x cubed, x to the power 7, and x to the power 5. So which one will be the lowest exponent there? 3. So then we will say the GCF is x cubed. Now let's see why. If I have x cubed and I expand it, it will be x times x times x. If I have x to the 7, it will be x times x. 4, 5, 6, 7 times. And then x to the 5th will be x times x times x times x times x. And so let's see what do they have in common. So they have one x in common, they have a second x in common, and they have a third x in common, and that's it. So that's why it makes sense that you take the variable with the lowest exponent. Now let's look at the next problem. So we have the GCF of y to the 4th power, and y to the 7th power. And keep in mind, what will be the exponent of y?
1.
A 1, right? So which will be the variable with the lowest exponent here? Just y, right? Y to the 1st power, or simply y. All right, now let's work with numbers and variables. So when I say numbers, I mean they have a coefficient greater than 1. So first problem here, we have 6x squared. So I'm going to do the prime factorization of that. So that will be 3 times 2 times x. I could say x times x, or simply x squared. Now we have 10x cubed, and that will be 5 times 2 times x cubed. We have negative 8x, and so it will be 2 times 2 times 2 times negative 1, of course, and then times x. So let's see, what do they have in common? And so they all have a 2 in common, right? That's it. That's all they have in common. And which will be the variable to the lowest exponent? Just x, right? So the GCF of 6x squared, 10x cubed, and negative 8x will be 2x. All right, now let's look at the next example. We have negative 18y squared. So here we will have, I'm just going to factor out the negative 1 first, and then we will have 3 times 3 times 2, because 3 times 3 is 9 times 2, that's 18. And we have y squared. And then for negative 63 y to the 3rd power, we will have negative 1 times 3 times 3 times 7. And then y to the 3rd power. For 27 y to the 4th power, we will have 3 times 3 times 3. That will give me 27. And then y to the 4th power. So let's see, what do they have in common? All of them, you can see they have a 3 in common. And then they also have a second 3 in common, right? And that's it. And which is the variable to the lowest exponent? Y squared. So in this case, the GCF for that list of numbers is going to be 3 times 3, or 9, y squared. Okay, so now I want you guys to work this problem out. So remember, you need to tell me the variable with the lowest exponent for A and with the lowest exponent for B. So let's check our answer for example 3, part C. And Angel, what do you get for the GCF of those 3 terms?
B.
Just B?
Oh, I got A cubed B.
A cubed B. Very good. And so yesterday, some students told me B squared, but they were overlooking that B to the 1st power there. So very good. That is the GCF.
Oh.
Yes.
I was about to say, I only got a normal A because it wasn't a common grades factor, but these are just...
No, well, we were still getting the greatest common factor.
Because I forgot about exponents just being... Because when you multiply exponents, you only add, so it didn't really matter. You just took the lowest.
Well, if we were to take a to the first power, it will still be a factor, but it wouldn't be the greatest. All right, so I have bad news for you. The next two slides, you don't have them printed, so you're going to have to write down the problems. So for example 4, what we need to do now is factor out the GCF. Before, we were only finding the GCF. Now we're actually going to factor it out. So we're going to take the first example, example 4a. So we have 6t plus 18. And so would you guys agree that we could, well, first, let's find the GCF. So would you guys agree that both numbers could be divided by 2?
Yes.
Yes, right? But however, that's not the greatest. Which one?
6.
3 bigger than 3?
No.
6.
Oh, 6.
6.
Is 6 prime?
6 is not prime because it could be divided by 3 and
You just said
2.
you could only use prime numbers, right?
To write the prime
Oh,
factorization.
Oh, that's why I said.
Oh. But then once we do all the prime factorization, we combine them
Oh.
and then we multiply them. So let me show you quickly what I
What
mean.
you're telling me is just to use prime numbers. Doesn't even doing.
So right here, we only use prime numbers
Yeah. So that.
to do the prime factorization. But then after that, the GCF was the product of the prime numbers. So 3 times 3, and then we said 9. Okay?
So I did my calculation wrong, but I also got it right.
All right, so we have 6. And then here, one way to check is you look at the lowest number, and then you ask yourself, could that number divide the other one evenly? And the answer is yes. So 6 could divide 18. So in this case, the GCF will be 6. Do we need a variable there?
No.
No, because 18 does not have a variable. So if we want to factor out 6 from here, we factor out the 6, and I want you guys to think in terms of division. So I want you to do this in your head. 6t divided by 6, what is that equal to?
1. Well, t.
1t, or just t. And for 18 divided by 6, that is 3. All right, so that is what it means to factor out the GCF. Now let's do the next problem. We have y to the 5th power minus y to the 7th power. So the GCF here is going to be y to what power? 5. Okay, so when we factor out the GCF, which you already told me is y to the 5th power, what is y to the 5th divided by y to the 5th?
Why?
1.
It's 1, right? Or if we were to subtract the exponents, it will be y to the 5 minus 5, which is y to the 0, and we already know that is equal to 1. So, unless it's 0, yes. So that 1 goes here. Now, if we factor out y to the 5th from here, we will have negative y to the 7th divided by y to the 5th. So what do you get when you divide a negative with a positive? Negative. And if we subtract the exponents, we get y to what power?
Y to square.
Square. So that will go here. Okay. Let's do the next problem.
So that would be our answer, 1 minus y2.
Yeah, the whole thing.
Oh,
Yes. Okay, example 5. So let's determine what is the GCF first. So which one is the number with the smallest absolute value? Negative 3, or let's just say 3, because I asked you guys absolute value. We could also factor out negative 3, but we're trying to factor the greatest. So if we take the negative 3, that wouldn't be the greatest. Yeah. However, sometimes it's more convenient to factor out a negative number, and you'll see that in a minute. So here the GCF will be 3 at what variable should go with it? Just a. So from here, I'm going to factor out 3a. So from the first term, I have negative 9a to the 5th factor out 3a, so it's like I'm dividing by 3a. So it will be negative 3 to what a to what power? 4. So remember here, a to the first power, you subtract the exponent. This term here will go here. There's a negative. The next term to factor is 18a squared, and we're going to factor out 3a. So what is 18 divided by 3?
6.
And a squared divided by a?
A.
Okay, so that will go here. And the last one, we have negative 3a divided by 3a. So that will be equal to what?
Negative 1.
Negative 1, and that's it. Negative 1. Okay, we're going to go to the next slide. You also need to write down the problems. Before you write example 9, I want you to write the following. So write down that problem, and I want you to look at it and tell me what factor do those two terms have in common? W, right? It's pretty obvious. I even made it red for you. So the GCF here is W. So if I factor out W from here, it will be like 5W divided by W. So what does that equal to? 5. And if I factor out W from here, we have YW divided by W. So that will be just Y. Okay, now copy that problem, please. And also example 10. Recording. Now moving on to example 9. I want you to look at both terms and tell me what do they have in common now. X plus 3, right? So now the term they have in common happens to be a binomial. Or the factor they have in common is a binomial. So it is just like we had a W here. Now it just happens to be a binomial. So what I'm going to factor out from here is going to be x plus 3. And so once I factor that out, if I factor that out from here, what would I get? 5 plus y? Yes, from here I get a 5, and from here I get plus y. Very good, Samantha. So it's very similar to the problem we did here with the W. It just happens that the factor in common here, it is a binomial. So this is like the basis for factoring by grouping. Now let's do one more. What do they have in common now? It's also a binomial. A plus B. Very good. So we factor out A plus B. And so if we factor out A plus B from here, it's like if we were dividing that divided by A plus B. So A plus B divided by A plus B, they make up a 1. So we get 3m squared n. And if we factor A plus B from here, we have negative A plus B divided by A plus B. So that will be not positive 1, but negative 1. Okay, so we're going to stop the video here. And I will record the lesson on Friday, tomorrow, so that you guys could watch it during your awesome Thanksgiving break.
That was really fast.